give us a brief introduction in terms of who is Prof. Greyling and what led you into doing work with technology and in education?
Okay, thanks. It's good to have this opportunity. Obviously, it's always great to talk to us about something that's my passion. I'm Prof. Greyling, the Head of Department from Computing Sciences at Nelson Mandela University. I joined the university in 1984 as a first year and became an academic in 1992. For the past 25 years, my passion has been introducing computer science as a discipline to learners mainly in our province, but also across the country. And this project we're talking about today, Tangible Africa, was born in 2017 when my honor student, Myron Batterson, came to me and said, Prof, we need to develop a mobile app which we can use to introduce coding to learners where there's no computers, where there's no electricity, where there's no internet, therefore under a tree. So it was born in 2017, it's grown since then, and that's where we are today.
Great, beautiful work. And in your opinion, why is it important that kids are taught coding at a young age?
It's a multifaceted answer. The first one is obviously we're in an economy globally that needs software developers. More and more things are going online, more and more things are automated. So the software developing world needs that skill. And we specifically have found with research in the last 5-10 years that mainly in your rural areas and in your townships, where learners are not exposed to IT and technology and software, they have other career dreams, which are not really always mapped to the skills needed in the country. So first of all, it's just making learners aware of the careers out there in tech. But it's much wider than that. That's where we were in 2017. We want to introduce coding to learners. But it's now become actually just a tool to another means, and that is introducing or enhancing problem solving. We see, and I think a lot of people in education will say that's the biggest problem in South Africa, that many of our learners can't solve problems. You'll find a lot of schools where they're going for good matric pass rates, etc. It unfortunately becomes more rote learning, training to pass an exam, rather than developing a lifelong skill of solving problems, strategizing, communicating, listening, talking, working in groups, the 21st century skills. So coding is for us on both these levels, introducing the coding careers, but also as a tool to introduce the 21st century soft skills to learners from grade R.
Thank you. And the infrastructural challenges that we have within our country, how can we collaborate in terms of bridging some of the challenges, and what are some of the challenges when it comes to coding or implementing coding in rural areas? What are the challenges that are?
The most obvious, tangible, concrete challenge is computers in schools. I saw statistics from last year from TBE. There's about 25,000-26,000 schools in South Africa. 16,000 of those schools do not have computer laboratories. So when you're talking coding and you're thinking computer laboratories as the only way to teach coding, you're immediately excluding what 60 to 70% of your learners in the country. You must be aware of the term digital divide. So we're going to be dependent on devices and fancy computers to teach coding. We're literally just keeping a lot of people on the side of the digital divide while the minority are taken further. So that is the first main challenge. The second one is teachers in South Africa have never been taught at varsity to teach coding. Well, the majority of teachers, 90%. So if we want to bring coding into the schools and we're dependent on conventional coding mechanisms or languages like Python, Java, or C#, we are making your teachers so nervous that they're never going to be able to implement it. So for me, those are the two biggest challenges. You also asked how do we address that, and that's where we as Tangible Africa comes in. We said from day one, the day that Byron walked into my office, we want to do coding without computers, without electricity, without internet, without a high barrier for the teacher. The teacher must feel empowered to do it, but we want to keep quality. And that's a global term called unplugged coding. In our context, we call it tangible coding, but both refer to the fact that we don't need these fancy computer laboratories. It has been estimated in South Africa, if you want a connected lab in a school, the average cost is around R1 million. So if they want to put computer labs that's connected to the internet in those 16,000 schools, we're talking 16 billion rand. And no person in his right mind is going to say they're ever going to do that. No, no government can implement that. So we need to find an alternative.
And if you were to explain to a non-technical person what is coding, what do you mean when you say tangible or unplugged? How would you explain that?
Okay, well, what is coding? That is the first elements of our training. We call it demystifying coding. And the first thing we teach the teacher and the learner is that coding is literally just a list of instructions that tells a computer what to do. And the analogy we often then use is any recipe in the kitchen, which is a list of instructions that tells the chef what to do. So as soon as teachers understand that, coding becomes much more concrete. It's just a list of things that tells your computer what to do, or tells your cell phone what to do. So if you're on WhatsApp and you're playing on WhatsApp, there's a program, coded program somewhere in the background that's telling your device how to do WhatsApp. That's coding. Coding in primary school, which we are focusing in, that's what we talk about, unplugged and tangible coding, is often done on what we call a grid. I think a chessboard with blocks, and moving something around on a grid. That's where block coding comes in. Some of your viewers might have heard of Scratch. Block coding is typical in people from my age will remember Lego coding from the 90s, 80s. Is typically moving something around on a grid. So it's still a list of instructions that tells the robot what to do, whether it's a physical robot, you often see these videos of robots moving around on the table, or whether it's a virtual robot on your cell phone screen. It's a robot that's told what to do. So block coding would be move forward and left and right, move backwards, and then some we call it repetitive structures for people that know coding loops. And then some decision-making code, if statement. So if there's a wall in front of you, turn left, otherwise go forward. Those kind of commands, if you put them inside each other, nested coding structures, it becomes quite complicated. So the coding games I'm talking about, which is tangible coding and block coding. And the first time I did level 30, as someone that had been coding for 20 years, it took me 90 minutes to solve. So when you say block coding or tangible coding, it doesn't minimize the complexity. It's just easier to start off and then you build up complexity.
And how many kids have you've impacted with TEGs so far?
It becomes more and more difficult to count because it's taken a life of its own. Just an example. Last night I was on Facebook and suddenly this Facebook post popped up. I think they call themselves Bite Buddies in Lusaka. They're doing our coding, and I've never heard of them before.
Oh, wow.
So if we count, estimate conservatively, since 2017, we think at least 200,000 learners, mainly in South Africa, but also across about 8 countries in Africa. We have footprints in Europe, in Asia, North America, and in May we'll be in South America. And then the one that we can count, if we've introduced teachers, mainly through the teacher unions, to block coding or unplugged coding, and then we've introduced about 40,000 teachers since the past 3 years into this concept of block coding.
And do you have any plans, or what is your vision beyond block-based coding for kids in Africa? How does that look like? Do you have any plans of taking these kids from block-based coding into textual-based coding? What is the transition plan looking like of these kids?
Yeah, that's a very interesting question, and we often fight with this concept, debate it, because it's obviously very tempting to say, okay, now we've got these kids, now let's teach them Java.
Yes.
But we're steering away from that for more than one reason.
Yes.
Firstly, we see our mandate is low budget, awareness, problem solving strategy. So for us, unplugged coding does that for us. We also feel very strongly that a kid in primary school does not need to become a software developer yet. You've got the guys in the fancy towns and fancy cities, private schools that have fancy labs, so they can go and code. But if we want to start teaching coding to the kid in primary school, we're going to just widen the digital divide. So our strategy has been, let's use unplugged coding, block coding, tangible coding, to make kids aware, to get kids to start to think and problem solve, but to make them hungry for the software development. But then we go back to basic and we say to them, okay, we're not going to teach you Java, but if you want to become a software developer, you need a good matric. So ours is the long view. We then spend time on nurturing them in their maths and their science. So it doesn't help I'm teaching you Java and you go and fail maths and matric, you don't know it. Sure. So we have this long view of making them aware, making them hungry, and then putting them back to basics with tutoring, teachers, etc. Once you go and have a good matric, then you come to university or to a Tibet college and you go and learn how to code. So we have about 15, 20 learners that's gone that long route. They're now in university doing BSc computer science, computer engineering.
Wow.
So that's our long view. We do not see it as our mandate to start teaching Python in primary school. I'm not saying it's wrong. I'm just saying as soon as we go there, we need computer labs, etc.
Yes.
And we're excluding learners.
And what's the one thing that excites you about this work, like the work that you're doing?
Well, the Facebook post I got from Zambia last night.
How lovely.
It's anecdotal of what gives us goosebumps. When someone in an area where the kids would never code, would never think of coding. They've got a little cartoon that say there. And then Tangible Africa came, and now we can teach our kids coding. I've got goosebumps as I say it. If I get a photo underneath a tree in Uganda, they're teaching Tangible Africa. I've got a photo of the Maasai kids outside a hut in Kenya doing coding. Deepest rural Eastern Cape. That makes us excited. And secondly, if we get a video from a teacher that said, I hated coding, I was so scared of coding, but you guys have opened it up to me. I'm now teaching coding in my school, although I've never coded before, and I feel empowered. We get teachers that put it on their CVs and they get full-time employment because they can do unplugged intangible coding. So this concept of, we like Mandela's quote, I never can get the words right, but basically says, the daughter of a farm worker can become the owner of the farm.
Yes.
The daughter of a peasant can become a doctor. So we like those stories that show where we're taking the daughter of a farm worker to become a computer scientist. The son of seamstress to become a business analyst. Those stories give us goosebumps.